Okay, so on Friday we started talking about arithmetic sequences. So I'll quickly go over what arithmetic means. Arithmetic means that there's a common difference, D, between each term. So we're increasing or decreasing by a common number by adding or subtracting. So go ahead and for number 1 and number 2 here, I want you to find D. Find me the common difference. What is the number we are adding or subtracting to get to the next term? Go ahead and write it down on your paper. All right, for the first one here, D is 6, because we're adding 6 each time to get from one term to the next. So that makes this an arithmetic sequence. If you are adding or subtracting a common number to get to the next term, then that is what it means to be arithmetic. Here, though, are we adding in number 2? What are we doing? We're subtracting. And what are we subtracting? 5. So D is going to be -5. If we're subtracting 5 each time, then that means that our common difference, D, is -5. The other thing that you need to be able to know about an arithmetic sequence is A1. What does A1 mean? The first term, right? A1 means the first term. What's A1 for this sequence? 3. What's A1 for this sequence? 32. And the reason why we want to know those is because we can create a general formula or an explicit formula for arithmetic sequences if we know A1 and D, okay? So these 2 equations we're going to use today. We talked about them on Thursday. For the quiz on Wednesday, you need to have these memorized. I will not be giving you these equations, and we're going to get 2 more equations tomorrow, okay?
Good morning, teachers. Please pardon this interruption. Breakfast is no longer in LGI. It will now be in the teacher's lounge. Thank you. Have a good day.
So we'll talk about how to use this in just a second here. But one thing I want to talk about here that we did not talk about on Friday is I want to talk about a recursive formula for a arithmetic sequence, what it looks like to have a recursive formula, okay? So if you have a recursive formula here, let's just use it to find the first couple terms. Do we need to find the first term? No, they already told it to us. What is the first term? 6. They told us right here. So then if you want to find A2, what are we going to plug in here for N? What did we just plug in for N?
6.
Nope. Look at what's right here. What number is right here in the N spot? 2. So what are you going to plug in here for N? 2. So this will be A2 minus 1 in the subscript minus 2. Well, what is 2 minus 1? Well, it's 1. So we will be doing A1 minus 2. Well, do we know what A1 is? Yeah, that's the term before, right? This is why this is recursive, because AN minus 1 means the term before AN, right? 1. You subtract 1 from N, it's going to be 1 less. So that'll be 6 minus 2, which is 4. And then if we find A3, our N is 3. So now it's A3 minus 1 minus 2. So that'll be A2 minus 2. So what number are we going to subtract 2 from now? What is A2? 4. We just found it, right? A2 is 4. So take the previous number and subtract 2. So then you would end up with 2. But we don't need to keep plugging in these numbers each time. That's a waste of time. What are we doing to the previous number every single time? What does this say right here? This is the previous number. What are we going to do to it? Subtract 2. So what's the next number going to be? 0, right? Where are we at right now? 2. And if you take that number and subtract 2, where are you going to be? 0, right? What's the next one going to be? -2. What's a 6 going to be? -4. So what are we doing every single time? We're subtracting 2. And that's really easy to tell from this recursive formula. So do we actually need to plug everything into the formula each time? No, I mean, you can, but that's a lot of work. If you can realize when you look at this, if you know what recursive means, and you know this is saying take the previous number and subtract 2, you already know this is an arithmetic sequence because you are subtracting 2 every single time. So here, this guy right here is D. This is your difference. -2, right? 6, 4, 2, 0, -2, -4. We are subtracting 2 every single time. So that's your D. Okay? We'll come back to that in a second. So it's really nice when something is written recursively, you can figure out what D is very quickly. Any questions about that? Because that was new. We did not talk about that on Friday or on Thursday. Okay, so on Thursday what we did is we took these this general term formula and we wrote explicit formulas for our sequences as long as they're arithmetic. This only works for arithmetic sequences and as long as we know A1 and D, okay? So, for example, here in question A here, we know that A1 is 5 and D is 3. So we can create an nth term or general term explicit formula to find any term an, right? Just like we did explicit formulas last week, if we know A1 and D, we can create a general term or an nth term formula. So what did they say A1 is? Well, that's 5. We're going to leave the n minus 1 because we want this to be in terms of n, so that it's a general formula, and then D is 3, so times 3. So now we have an explicit formula, right? Could I find A55 with that formula if I wanted to? Could I find the 55th term? What would I do if I wanted to find A55? Just plug in 55 for n, right? If I wanted to find A100, I could find A100, right? It's an explicit formula. They asked us to find A10. So now we did the first step. The first step was to write that general nth term formula, and now I want you to use that to find A10. So you should have gotten 32 as your A10. We are going to plug in 10 for n. So this will be 5 plus 9 times 3, so that should be 32. And we could find any term we want with this general term formula. Now, this only works if it's arithmetic, okay? Tomorrow we're going to get a different formula for geometric sequences, which are when we're multiplying or dividing to get to the next term. So this only works if you are adding or subtracting by a common number to get to the next term. Okay, for B here, they also want us to write the nth term formula for an, and then find A10 once we do that. We need to know two things to write this formula. We need to know A1 and we need to know D. Which one of those did they tell us in B? They gave us A1. They told us it was 6. Did they write out what D was equal to, like in the last one? Did they write out, did they say D equals blank? No. But guess what? You can very quickly tell me what D is. Yes, D is just 5. How do we know that? Well, this is a recursive formula, right? And what does it say to do? It says to take a minus 1, the previous term, and do what? Add 5. So what are you going to do to the previous number every single time? Add 5. So we actually do know what D is, right? This is the recursive formula. So they tell us right here that D is equal to 5 because they give us the recursive formula. And if you add 5 to the previous term, that's literally what it means to be D, right? To add 5 to every number each time. So they actually did tell us D. So go ahead and write down what your general formula will look like then, your explicit formula, now that you know A1 and D. So it should be 6 plus n minus 1 times 5. Okay? Do not put a 10 in there for the n yet. Okay? We are trying to write an nth term formula, an explicit formula to find any term we want. That's what the first thing was asked for, an, a formula to find any term. So there needs to be an n in that formula. Now, for part 2 of this question, they ask us to find A10. So now you can fill in 10 and find what A10 is. But they also asked us to write that formula so we could find any term that we want. So go ahead and find A10 if you haven't already. You should get 51. 6 plus 10 minus 1 times 5. That'll be 9 times 5 plus 6. So A10 is equal to 51. Could I also have found A100 with that formula if I wanted to? Could I have found the 100th term? Yeah. Could I have found the 50th term? Yeah. So anytime I want to find any term in the sequence, I'm going to use this formula for the general term. This lets us find any term. That's what AN means. It means the nth term. If it says A20, it's the 20th term. If it says A50, it's the 50th term. Okay? Any questions about the general term formula? That's this one right here. Especially for those that were not here on Thursday. Okay. The next thing we're going to do and the last thing we're going to do today is we're going to use this other formula here. We are going to use it in a little bit of a different way than we did on Friday. We're going to go a little bit further with it. We'll start with the basics, or I'm sorry, on Thursday. We'll start with the basics, okay? This formula here, SN, is different than the AN formula. What do you think S stands for? Or do you remember what S stands for? Sum. It stands for sum, okay? But not the sum. So with this guy, S, it stands for the sum of N terms, okay? So, for example here, this guy here is a sequence. First, let's check to see if it's arithmetic, because we can only use these formulas if it's arithmetic. Is this one arithmetic? What's the pattern here to get from one term to the next term? Adding 4. So does that mean it's arithmetic if we're adding 4 every time? Yes. Yes. Adding or subtracting a common number means it's arithmetic. So we can use any of these formulas here on this guy, okay? If I asked you to add up the first 3 terms, could you do that? Could you add up the first 3 terms? Find the sum of the first 3 terms? Go ahead and do that. Find the sum of the first 3 terms. What's the sum of the first 3 terms? 15, right? 1 plus 5 plus 9 is 15, okay? What if I asked you to find the sum of the first 5 terms? It would take a little bit more work. It'd take a little bit more work. What would you have to do to find the sum of the first 5 terms?
Add 4 to the last term and then add all 5 of those terms.
You'd have to say, oh, well, I know the next one is 17, right? Because of, I'd have to add, or wait, yeah, that's right. Yes. Okay, wow, doubting my basic arithmetic there for a second. And then you would have to add those up, right? What if I ask you to find the first 100 terms, like this question asks?
It's doable. You need a lot of paper.
Do you want to do that? Probably not, right? You'd have to write out all 100 terms and then add them all up. Well, that is why this formula is helpful, because this will find the sum of however many terms we want. So if I want the sum of the first 100 terms, I'm asking to find S100. That's what that formula means, S100, okay? The sum of the first 100 terms. So not the 100th term, A100 would be the 100th term, right? S100 is the sum of the first 100 terms, okay? So let's go ahead and fill in this formula. What did we just put in here for n? 100. So what are we going to put here for this n and this n? 100. So it will be 100 divided by 2 times A1 plus A100. So the nice thing about finding the sum of the first 100 terms is all you have to know is how many terms you're adding up, and then you only need to know the first term, A1, and the last term, A100. So you don't need to know all those numbers in between. That's all you need is the first term and the last term. Which one of those do we already know? The first one. What's A1? 1. So we can go ahead and fill in that part of the formula. Do we know what the 100th term is? A100. No, we don't. They didn't tell us that. So we need to find one more thing before we can calculate the sum of all 100 terms. Well, do you know how to find the 100th term of an arithmetic sequence?
Yeah, we did it just on the other page.
Didn't we just do that? Didn't we just find any term we wanted with the general formula? Isn't that what this tells us to do? If I want A100, can I use this formula to do that? Yes, okay? So now what we're going to do is we need to find A100. We don't know what A100 is, so we can go use our general term formula. We know what A1 is. That was 1. Now we can go ahead and plug in 100 for n since we're finding A100. Right? We already put a 100 in here for the n, so we'll put 100 in here. And then we just need to know D. And what did we already say D was? Plus 4, right? Because we're adding 4 each time. So D is equal to 4. Go ahead and calculate then what the 100th term is. Yes, 397 is what you should have gotten. 99 times 4 plus 1. Now, can I finish my formula here? Can I finish my formula now? Now do I know what A100 is? What's the A100? 397. So now I can plug that in here and finish my formula. So go ahead and do all that arithmetic, that math, figure out what your final answer is here for your sum. You should get 19,900, as long as I did my math right. Yes. Did we get that number? Yes. Okay, this is probably the most complicated thing that we did on Thursday. Are there any questions about what we just did here, this process? We're going to do one more. Make sure you understand it. Okay, let's do another one. This one asks us to find the sum of the first 58 terms. First, we need to, well, I said it's arithmetic, but let's double check. Is this arithmetic? Are we adding or subtracting a common number to get from one term to the next term? Yeah, what are we doing? Plus 2, right, each time? So this is definitely arithmetic, so I'm allowed to use either one of these formulas. These formulas here are both for arithmetic, okay? We're finding the sum, so which one of these formulas should I start with? The bottom one, right? S stands for sum. So I want to find the sum of the first 58 terms. So I'm going to put a 58 in there. I do not want to write out all 58 terms and add them up. I want to use the formula. So we're going to plug 58 in for n. In all the n's, since we plugged a 58 here for n. Do we already know A1? Yes, that is 1. First term is 1. So we can go ahead and plug that in. But what do we not know? The 58th term, right? They didn't give us that. So we're going to find that one, right? That would be the 58th term in this list. We'd have to keep adding 2 until we get to 58th term if we want to do that. You could do that, or how can you find A58? This formula, right? Use this formula here. Because you could add 2 until you get to the 58th one, but that would take a really long time. So use this formula to go ahead and find A58, and then plug it in to find your final answer. And then we're going to do a couple more slightly difficult problems today. All right, for A58, you should have done 1 plus 58 minus 1 times 2, because A1 is 1. Our common difference, D, is 2, because we're adding 2 every time. And then to find A58, you're plugging 58 in here for N. And for that, you should have gotten 115. We get 115 for that number. Now that we know that, we can go plug that back in up here. And we should get 3,364 as our total sum. Sometimes these are really big numbers, right? Because you're adding up a lot of numbers. You're adding up 58 numbers to get that sum, right? So that should be a decently big number, unless your numbers are really tiny, okay? Any questions about that one? All right, so if you weren't here on Thursday, we just did everything that we did on Thursday. A little bit faster. And now we're going to do 2 slightly trickier problems that we did not tackle on Thursday. So any questions about what we've done so far?
I wouldn't even know what question to ask.
Okay. Did you understand what we did so far? Okay, let's do 2 more tricky problems here. This asks us to find the sum of all the even numbers between 43 and 79, okay? Let's just start to make the list of even numbers between 43 and 75, okay? We're not going to write out all of them because that's a lot of them, and that takes a lot of time, but let's start. So what would be the first even number between 43 and 79? 44. What would come after 44? 46. Then 48. 50. And we'll just write ... because we're not going to write out all of them. We want to sum all of them up, okay? Am I allowed to use one of these formulas to do that? Is this an arithmetic sequence? Are all the even numbers, is that an arithmetic sequence? Yeah, what are we doing to get from one number to the next number? we're adding 2. So that, if I'm talking about all the even numbers, that really is an arithmetic sequence. So which one of these formulas should I start with if I want the sum? Sn, okay? Now the tricky part about this is how many numbers are they asking us to add up? They don't say how many there are. How can we figure out how many there are? Any ideas? How many even numbers there are between 79 and 43? Yes, 79 minus 43 divided by 2. Because we want to know how many, every other number is even, right? So if we subtract those two numbers and then divide by 2, that will be how many even numbers there are, right? Because if we subtract them, then that will be the difference between the two numbers, right? So this one, that's the only tricky part, is we don't really know how many numbers are in that list. We have to think about that, right? So how many numbers are there in this list? Well, if we do 79 minus 43 divided by 2, we get 18. So here, they're asking us to find the sum of the first 18 numbers in this sequence. I would like you to finish this one on your own. That's the only really tricky part about this one. There is also a nice little shortcut you can use for this one to find your last term. You don't necessarily have to use the formula on this one. But go ahead and try to finish that.
A1 is 44.
Correct. All right, so when you first start to fill in your formula, you should have 18 divided by 2, A1 plus A18. We already know what A1, it's the first number in our sequence. A1 is 44, because remember, we're adding up all these even numbers. So that'll be 18 divided by 2 times 44 plus, and while you can use this formula here to find A18, I think you actually could tell me faster what the last number in this list is. 78. Not 79, because that's the odd one. But 78, because we wanted all the even numbers between 43 and 79. What's the last even number before 79? 78. So you actually don't have to use the formula in this case, right? If you do, you should get 78. If you did not get 78 for your last number when you did your formula, then you did something incorrectly. It would have been 44 plus 18 minus 1 times D, which is 2. But that's the nice little shortcut on this one, is that you don't really need to find A18. You already know what it is if you just kind of think a little bit. So if we do that, 78 plus 44, we should get 1,098 as your final answer. Any questions on that one? A little bit different. than the last one, but same formula. Okay, last question here, number 8. It's a little tricky. It asked us to find the sum here. Well, we already know this is sum because this is what sigma notation means, right? It means find the sum, okay? But we don't have our list, so let's make sure this is arithmetic before we start using any of these formulas. So to do that, let's just write out the first couple terms. We don't have to write out all of them, but let's write out the first couple terms. How am I going to find the first number in my list? Where does this sum start? When I is equal to 1, right? They're using I instead of K, but that's not different, right? They can use I, K, and the different numbers, letters they like to use. So what do we do to find the first number? We take 1, and what do? Put it into the formula for I. This is a little bit of review from last week. So I equals 1 would be 5 times 1 minus 9. So that will be -4. That's the first number in our list. What do I put in next for I? Do I go straight to 25? What goes next? I goes up by how much? 1 each time, right? So next we plug in I equals 2. So go ahead and let's just do the first 4. So 2, 3, and 4. We won't go all the way up to 25 because that would take a long time. We could, but that would take a long time. So we're going to use a formula to help us do that instead. But go ahead and plug each of those in and see what your first 4 numbers in your list are. All right, you should have gotten 1 when you plugged in 2. You should have gotten 6 when you plugged in 3. And you should have gotten 11 when you plugged in 4, okay? Now, technically what we're supposed to do, remember, we're supposed to be adding all of these numbers up, right? And I should technically keep going 5, 6, 7, 8, 9, all the way up to what? When would I stop plugging in I? 25, right? So technically, I should keep doing this until my very last one, right? When I is what? What would be my very last one? 25. So go ahead and find out what that one would be. Because remember, the top limit tells me where to stop. Do we get 116? Yeah, 116. 5 times 25 minus 9. 116. Now, last week when we did a problem like this, we wrote all the numbers out from 1 to 25. I didn't make you do one from 1 to 25 last week. Like I maybe made you go from like 1 to 10 at most, right? Or 1 to 6 or something like that, right? I didn't make you do all of those numbers. If you were desperate, could you plug in 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and then add all those up? Yes. Do you really want to do that? No. And do we have a shortcut for how to do that? Is this arithmetic?
Yes.
Yeah. What are we doing to get from one term to the next? We're adding 5, right? Plus 5? Plus 5? Plus 5. So is this arithmetic? Yes. Can we use one of these formulas then? Yes. And so that's going to save us the time and energy that we had to do versus how we solved this kind of problem last week, since it has so many numbers. I purposely did not give you one this long last week because you didn't know these formulas, right? And you could do it that way, but it's going to take a long time. So which one of these formulas should we be using, though? The bottom one, because what do we want to do with all these numbers? Add them up. And what is this one for? Sums, right? So adding. So we're going to do sum. And we want the first 25 terms, right? Because we start at 1, we're going to plug in 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 25. That's going to be 25 numbers, right, that we've plugged in. So we're finding the sum of the first 25 terms. So we're going to plug 25 in for n. Do we know what A1 is, the first term in our list? What's A1? -4, so let's go ahead and plug that in. In a few of the problems earlier, we used this to find A25, but you don't need to do that. You could, but you don't need to. Do you already know what A25 is, the last term? Yeah, it's 116. You already did that, right? You already found A25. This guy right here is the 25th term, the last one, right? And this one right here is A1, the first one. So you already know what A25 is. It's 116. So then go ahead and plug all that in and find your total sum. You should get 1,400 as your total.